Pretty important day, a pretty important lesson. After today, well, every lesson is important, but as we get more and more advanced, after today, we should be able to do about 80% of our integrals. There are more of our integrals, AB integrals. There's more. There's partial fraction decomposition. There's indefinite. There's a whole bunch of more integrals. Integration by parts, all that good stuff. The BC ones. I'm just talking about the ones for our tests. So after today, you should be able to tackle about 80%. We still need to integrate with respect to y. We haven't done those yet. After we do that, then you'll be able to cover about 90%. And then we just need special ones like completing the square and stuff like that, long division. After that, then there'll be 100% of AB stuff. So we're almost done. Yeah. Where we have to do long division for the integrals. All right. So here we go. So right now, what's the difference between an indefinite integral and a definite integral? Yeah. Good job. You've been listening. This, if I define it, quote unquote, define, haha, play on words. If I tell you this is, what is this one called? This is called a definite integral because it's defined. Can't even spell.
Yeah, that's right.
Definite.
Also, it's indefinite whenever you use variables, or what? No, it's indefinite whenever you don't use variables.
Definite. Sorry, I'm off today. A little bit, not much. All right, so indefinite integral, this would antiderivative of f of x would have been antiderivative of f prime of x would have been f of x. And you evaluate that from a to b. So that's just f of b minus f of a, and that has some number, right? An indefinite integral looks like this. What's the difference between the definite and indefinite? Yeah, you don't have the upper and lower limits. This is just f of x, and then you say what? Plus c. So if it's an indefinite integral, you put a plus c. Oh yeah, don't forget your differential. Man, can't believe that. LOL. You gotta have your differential. You gotta have that dx because it's a summation of rectangles. Delta x times the height. So you gotta have the dx. All right, here we go. Example 1. We're gonna go slow. Hopefully by now we've done enough that these are just like a walk in the park. What's antiderivative of x squared? What's antiderivative of sine x? Positive or negative? Plus cosine x. And because I don't have any limits, I put a plus c. Here are some formulas for indefinite integrals. I'd like to, well, I guess later on let's add one. Let's add two. You see these right here? Let's put a linear expression inside the argument here. So I'm going to write it like this. Integral of sine of, what letter do you like, K or C? C, where C is a constant. No, let's not use C because we're using C also for the plus C. So let's use K. Ku du. Antiderivative of that, remember chain rule. So the antiderivative of that is negative cosine of Ku plus C, but I'm missing something in the front of this. Do I put a K in the front or do I put a 1 over K? 1 over K, the reciprocal.
Oh.
Why am I putting the reciprocal? Because of chain rule when I take the derivative. Negative 1 over K, the derivative of cosine is a negative sign, so negative times negative go away, times K, cosine of sine of Ku times K, and then that will cancel out that 1 over K. Yeah. So look.
I didn't get that last.
Yeah, okay, let's do it. Look, yeah, it might be me. All right, guys, focus. Look, yeah, I know. That's why you're asked. Let's take the derivative of that. The K is a constant. What's the derivative of cosine? Negative sine, and I keep the inside the same, right? Times, what's the derivative of Ku? K du dx. Because I'm taking the respect to x. You know what? I should just, okay, I'll make it ddu, so it makes life easy for everyone. d du there. So I don't need that.
It'll just be K.
It'll just be k. So see, I have a negative k sine of ku.
But how did you get the 1 over K?
All right, that's a good question. Let's go back to this. Notice I'm doing an antiderivative. So if I take the derivative of this, do I get sine of ku? Well, I don't know. Let's see. ddu, let's do it with respect to u. ddu of negative 1 over k cosine of ku plus c. Okay, well, the derivative of that, the derivative of cosine is a negative, so that negative goes away. 1 over k sine ku. Now I got to do chain rule times what's the derivative of ku? K, and then the derivative of constant is 0. What's 1 over k times k? Do I have sine of ku inside my integrand? So whatever the argument is, if it has to be a linear expression. If you have to have a linear argument. You just take the reciprocal of whatever you have in there for when you're doing antiderivative. It's a linear because of chain rule. If it would have been a quadratic, then we're done. We can't do it. We have to figure out a different way, which that's in the next calculus level. Let me write a realistic example. So check it out, Miss Houston. Integral of sine of 3x dx. What's antiderivative of this? Well, you would probably say cosine of 3x for sure, right? Plus c, yeah, negative. And then notice if I take the derivative of this, I would have gotten a 3 sine 3x. But that I don't have a 3 in the front of that. So I need to have a 1/3 in front of this. That 1/3 is the reciprocal of 3x, or the reciprocal of the coefficient.
So you just need to make sure that they cancel out so that whenever you take the derivative of that.
Yes.
Okay.
So, and maybe I shouldn't have brought it up. You could do it with U-sub. That's what we're doing today anyways. But don't worry, Miss, I see you. So if you have, you can only do it for trig expressions with a linear argument on the inside. As soon as it's something else, like a quadratic on the inside, then it goes away and we got to do something else. What's the question, Ms. Kyle?
So you only do the chain rule with indefinite?
Well, we do it with definite as well. But maybe I shouldn't have even brought it up because that's the whole point of today. We're doing U-sub. But I just wanted you guys to see something fast. You don't, just because we're doing U-sub does not mean that you need to do U-sub, because some of you are faster than others and can see it faster. That doesn't mean anything, guys. It just means you just need more practice. That's all. Some of you will get this faster than others. Some of you will not need U-sub. You will probably say, Chav, why are you doing U-sub? I can already see it. Good for you. Not everyone can see it, guys. You do get to, once you do more and more of these, you do start seeing things a little easier, but it just takes practice. So these are my integral rules. It's the same, pretty much the same. Notice there's an absolute value on ln. That's because of the domain restriction. The domain of 1 over u is all real numbers except 0. So by putting the absolute value, you get the domain. Okay, you guys ready? Estamos listos. That's Spanish. I don't know how to say it in Vietnamese. If not, I would say it. But, okay. Sorry, Ms. Kyle. Do you not approve? Don't be mad at me, miss. You get mad real quick. All right. Paying attention to the differential. Here we go. F of x equals x cubed plus 1 and let u equals x squared. Find each of the following antiderivatives of terms of x. Okay, this one's not a big deal. So this one, it just says integral of x cubed plus 1 dx. And it says to find the antiderivatives in terms of x. So I already have it in terms of x. What's antiderivative of x cubed?
X to the 4th over 4.
Plus antiderivative of 1.
Plus X.
And then I put a plus c. Done. That's it. For that one, yes. All right. This one here, it says f of u du. Well, on the side, I'm going to write f of u, because f of x is x cubed plus 1. F of u is u cubed plus 1. Do we have any issues with that? Yeah, because they told us that f of x is x cubed plus 1. If they would have told us f of triangle, then we would have done triangle cubed plus 1.
I don't know.
F of happy face
No. Oh, I understand.
is happy face cubed plus 1.
I don't.
They told us the function de Leon is f of x is x cubed plus 1. Wherever you have the argument x is where I'm plugging in whatever that I have.
But if u is equal to x squared.
Yeah, well, we're not doing that yet. Look what this says. I have a differential of du.
And then we put in x squared
So,
cubed.
so first we got to do this one in terms of u. So f of u. So u cubed plus 1 du. Are we okay so far? No, not whatever I say. Like, tell me we're not okay.
And then do we plug in the u?
Right now, we just do antiderivative with respect to u because this integral is in terms of u.
So then it would just be the same thing.
What's the antiderivative of u cubed plus 1?
U 4 over 4 plus u plus c.
Okay, there we go. Now that I got this in terms of u, now I say, well, what does u equal? So now I plug in x squared for u. So I'm going to have x squared raised to the power 4 over 4 plus x squared plus c.
So it's x to the 6 over
No, not x to the 6. X squared raised to the 4th is x to the 8th over 4 plus x squared plus c. We're okay? Now look at the next one. The differential is x, but I have f of u. That one, so let's write f of u is u cubed plus 1. But I don't want u cubed plus 1. I'm going to integrate with respect to what letter? X. So I'm going to substitute what u is for x. Yeah. So I'm going to type, what am I going to type? X squared to the, yeah, you're already going right to it. Plus 1. We still okay? So this is integral. What's up?
So the last problem we plugged in after we found the antiderivative because we didn't find it in respect to u, right?
Mm-hmm.
And then now we're doing it before because we need to find it in respect to x.
Yes.
Okay.
You got it. What's antiderivative of x to the 6?
6 to 7 over 7.
Plus. There you go. Know the difference. Nothing crazy, right? All right, here we go.
All right.
Relax. It's going to be simple. Y'all ready?
You're hilarious.
So the whole point of U-substitution is to make it easy to integrate. So here's what you should be thinking. You see the sine x, you see the cosine x, and in your brain, something should be telling you, hey, sine x and cosine x are related. How are they related? Starts with the letter, starts with letter D. The derivative. The derivative of sine is cosine, and the derivative of cosine is negative sine. Do you guys see that? So don't write this down because this is wrong. If I were to do U-substitution, I'm writing this one wrong on purpose. So let's say I go, okay, let's see if this helps me. I'm going to go u equals sine x, and then I go du with respect to x, and I get cosine x, and then I go times dx, so I get du equals cosine x dx. Look, guys, I don't have a cosine x dx to replace. Let me rewrite it so you guys can see. I'm going to rewrite this first. E to the cosine x, sine x dx. This is all just a product. It's understood. Okay, the most common mistake is that sometimes you guys write the differential in the very beginning. The differential is known to mean the end of the integral. So always leave the differential. When I say differential, I'm talking about the dx. Always leave the dx at the very end. Cool? Look what you do have. You have a sine x dx right there. Do you guys see that? Okay, so now I'm going to do it the right way. So you can write this down. My u is going to be u. My u is going to be cosine x. Why is your u cosine x? Because when I do my du, I guess I'll write du dx for now. Du dx is going to be negative sine x. And then, don't worry, I see you, miss. Times dx. So I'm going to have du equals negative sine x dx.
So then you can substitute.
Yes, but don't, hold on, be careful. Don't worry, I see you, miss, because maybe your answer will be answered right now. Okay, you see how I have a sine x dx? I don't have a sine x dx. I have a negative sine x dx. Now, this is my route. The Delta Math doesn't do it this way, and I see a lot of teachers don't do it this way, and a lot of textbooks don't do it this way. I grew up with chemistry first, and in my brain, I always balance things out. So I do it the chemistry route, which is the equilibrium route. Do you guys remember when you did like balancing equations in chemistry? So here's what I do. I see a negative, and I force a negative. I go, oh, okay, I'm going to put all this in parentheses, and I'm going to put a negative right there. If I do that, then what do? I put a negative on the outside for balance. Just like in chemistry. Do you guys see what we're doing? Okay. All right. Did I answer your question?
No. So U is just some. It's a really basic question. So U is just some placeholder, right?
It's just a way to make this expression simpler. So now when I rewrite it, you can choose any letter. It doesn't have to be U. You could say W or whatever. Look, negative integral, and look, I'm just going to rewrite it. E to the U, and then negative sine x dx is just what?
E to the it's just negative sign. Oh wait.
Sine x. Isn't it just D?
Look how simple this is. Isn't that way simpler now? I'm integrating e to the u with respect to the letter u. Do I know what this antiderivative is? Yes, I put the negative there. That's from that one. Antiderivative of e to the u is just e to the u, and put a plus c. Now, I don't want it in terms of u. I want it in terms of x. So let's rewrite it. So integral of sine x e to the cosine x dx is simply negative e to the cosine x plus c. Now, I know some of you are strong enough because you've done hundreds and hundreds and hundreds of derivatives and integrals that you can probably see it and be like, Chav, I don't need U sub. I can already tell. I can already see the chain rule in there because I see the cosine x on the top. So the antiderivative of this has to be negative e to the cosine x, because when I take the derivative, negative e to the cosine x times the derivative of cosine x, which is sine x, and there it is. Well, negative sine x. Negative times the negative is a positive. Yes.
I have a question for Sally.
Bless you.
I always thought that I feel like we were more complicated to be distributed in a sense.
It is. It's width times height. But we're talking about differentials now. This is an infinite amount of rectangles being added up. Remember that all this means summation of f of x, the cosine x sine x, times their delta x. There's a whole bunch. No, that's a product. That's not a property.
Oh, okay.
That's not a property. It's only f of x plus g of x. You don't, f of x times g of x is, there's not a something that you can split. Yeah. Guys, did that make sense? Okay. Come on, Mr. Cruz, focus. I need your A game. I really do. I really do. Don't worry, because I want you to get a 5. Don't get mad at me. Just trying my best. All right, look at this next one. Chav, how do you decide what is u? That's the question. How do you decide what is u? You decide what is u based off what you have here and if it makes sense to use U-Substitution. I look at it and I say I see 5 plus 2x cubed, and look on the outside, I see an x squared. You recognize every time you take a derivative of a polynomial, does the degree go down by 1? Yes. So what am I going to make my u, Ms. Cruz? We just said right now, like when we take a derivative of a polynomial, the degree goes down by 1. So you're going to make u equal to, I need your A game, guys. 5 plus, this is why I need your A game. 5 plus 2x cubed. Focus, guys, focus. If I make that my u, when I take a derivative of this, it's going to be 1 degree lower.
Whose stuff is ringing?
Yeah, it's because there's something vibrating on the table and it's distracting.
Bro, right? Yes, there is.
Okay, look to see if there's something out, because I don't see anything.
I know it's not my phone because my phone's better.
Okay. All right, guys, focus. All right, here we go. In a little bit, we'll tear everything apart. I'm going to start writing it like this. du equals, what's the derivative of 5 plus 2x cubed? 6x squared dx. Does it bother you guys that I do it in one step like that?
Sorry, can you?
Oh, yes.
Can you do it?
Well, I did it over here, but I want to make sure that eventually you guys start doing it like this. du dx, I'm taking the derivative with respect to x, and it's just 6x squared, but then times dx, you're going to have 6x squared dx.
Wait, why isn't it okay?
Are we okay? Henderson, you doing okay? All right, here we go. I'm going to rewrite it so we can see it. Yeah, don't drink so much caffeine. Integral square root 5 plus 2x cubed x squared dx. I just rewrote it. It's all a product. The dx is the end of the integral. I'm going to change my colors. This is 6x squared dx. I right now at the moment have x squared dx. What does that need?
You force a 6.
I force a 6. If I do that, then what do I do on the outside?
You force a 6.
No.
Oh, 1 6.
1 6 to balance. This is how I do it. And I never, well, I'm not saying that I never make mistakes, I do, but with consistency, you always get these correct. You can do it the delta route. You'll see it in a little bit how delta does it. Yeah, they do. They get the x squared by itself by dividing this by 6, and then they put the constant in there, and then they pull it out 1 6. I don't like it, but I don't like it because I like the chemistry route. Books do that also. Okay, what's up?
If we're gonna multiply by 6, then why would we multiply by the reciprocal?
To balance, because then you just added a 6, you just added a multiple.
You just get to equal 1.
You have to make it a 1 to make it the same. Because we can't just add numbers, you know what I mean? All right, here we go. Here we go, guys. 1 6 integral. What is the 5 plus 2x cubed? Just u. And then the 6x squared dx is du. Is that a lot easier to analyze? Yes. Look, 1 6. I haven't solved it yet. U to the 1/2 du. There's my 1 6. I'm going to leave a little bit of space. U to the 3/2 divided by 3/2, which is the same thing as multiplying by plus c. 2 goes into 6 3 times. What is 3 times 3? So I see 1/9 u to the 3/2, which is 5 plus 2x cubed to the 3/2 plus c. We go back to our x in this case because we don't have limits.
So it's basically just using variables
To make it
to
simpler.
make it okay. And then plugging variables after.
In this case. How do we feel? You guys ready for another one? Don't worry, we're going slow, miss. Cotangent 7x dx. Do you guys happen to know an antiderivative of cotangent? Is it over here? Nope. We don't know. What the heck? No. It's an ln. Yeah. Yeah, you guys need more experience. You're not engineers yet. Here we go. Ready? Integral. I'm going to turn cotangent into what over what?
Cosine over sine.
Cosine 7x. Sine 7x. You still have that differential? Dx. Take a guess. What do you think you're going to make u?
7.
No. No. Okay, look at this, and you're saying, what will make life easier? I have a sine 7x, and I have a cosine 7x dx. There's my big hint. So u has to be sine 7x. So when you do your du, you have 7 cosine 7x dx. Do you have a cosine 7x dx? Yes. Okay, don't write this down because this is wrong. If you would have chosen u to be cosine 7x, then you would have had negative sine 7x times 7 dx. And then look, that sine 7x dx, you can't substitute that. It's at the bottom. Do you guys see that? Okay, so let me erase this. Okay. I almost have it. Don't worry, we're going slow. We're going to do a whole bunch of these until you guys get it. What am I missing for me to do a substitution? A 7. So I put a 7 right here on the outside for balance. Do you guys see that? Now I can go 1/7. I'm trying to color code, guys, of what I'm adding in there so you guys can see it easier. And then that 7 cosine 7x dx is just du. And then that sine 7x is just u. And let me write it simpler so you guys can see what the antiderivative is. 1/7 integral 1 over u du. What's the antiderivative of 1 over u? ln. 1/7 ln of u. Don't worry, I see this. Plus c. Because I don't have any limits and I wanted my domain to be all real numbers except 0. 1/7 ln of, really, this one has, well, okay, 7 sine 7x. There is domain restrictions on this, but we're not going to go there. Plus c. All right, what was the question?
Where does the dx go?
It goes away. I did the antiderivative. Remember? That was the whole point when we did the fundamental theorem of calculus. F prime of x dx is just f of x plus c. There's no dx anymore.
The integral's still there, so you have to.
There's no more integral. I don't have an integral here.
We substituted the dx because du is
I'm talking about the beginning.
It's right here. It's the d. That's not different. I moved it to the side so it could be easier to see. You hear me? Yeah, some books write it like that, but you're right. Maybe I should have written it like this the whole time. Blame it on textbooks. Okay. How do we feel right now, guys? Okay. Is this getting easier or no? No? All right. I'm going to go slow.
So it would just be integral of 1 over cosine squared to 2x dx.
Yes, rewriting it. Integral 1 over cosine squared 2x dx. But that's not, well, I guess you can do it started like that. What's 1 over cosine? So then this is secant squared 2x dx. And maybe you don't need u sub. Maybe some of you can already see it. I don't know. What's the antiderivative of secant squared? Tan. I have a 2. Let's see if we can. Should we do it without u sub? See if we can?
Yes.
Okay. Without u sub. Antiderivative of secant squared is tan. And I got to keep the argument. 2x plus c. Now, when I take a derivative, I take the derivative of 2x, which is 2. But I don't have a 2 in the front, so that means I got to have a 1/2. And there it is without u sub. Do you see how we did it? Okay, with u sub, I'll change the colors so I can do it again with u sub. With u sub, don't worry, we'll be done real quick, guys. It is cumbersome initially, but it's a good skill to have. With u sub, you go to the side and you say u equals 2x, du equals 2 dx. Do I have a 2 dx in there? Well, technically not yet, right? So I'm going to put a 2 right here. See? Whatever you do to 1, you do to the, or you balance it out by putting a, do you guys see what we did? And now look what I have. What color was that? Blue? I'm just doing it again, guys, so you guys can see it. Secant squared of u du. What's antiderivative of secant squared? It went away with the substitution. 2 dx. 2 dx is du. What's antiderivative of secant squared? Tan. And look. Then just plug in what your u was. 1/2 tan 2x plus c. How do you guys feel?
How do you find how do you know which one to use?
Whatever one is the one that you feel most comfortable with. Do you like the red one or the blue one? Or neither?
Like during use of how do you find the
You ask yourself, what can I do to make the integral easier to integrate? So like, let's say I'm stuck right here. And you're like, man, what's stopping me from doing that antiderivative? Like, well, I know what secant squared is, but there's a 2x in there. I guess I need to make the u a 2x. You know, you're not going to make the u equal to secant because the derivative of secant is secant x tan x, and I don't have a tan x in there to help me with my du. Does that make sense? So look, check it out. Look at this one. Letter B. Yeah, the more you do, the more you start figuring it out. So you see how this one is cosine cubed? There is no relationship between cosine cubed and whatever, right? So here's what we're going to do. You're going to write it like this. Cosine squared x, that's a squared, times cosine x, and then put the dx. Child, how does that help me? Well, Valentine's is around the corner. Cosine squared x plus sine squared x equals 1. And look, if I move that sine squared to the right, I know that cosine squared x equals 1 minus sine squared x. Do you guys see that? And I can rewrite this integral as integral, parenthesis, 1 minus sine squared x, close it, cosine x dx. And now, okay, don't worry, catch up. Are you ready, Kyle? Okay, then I'll wait for you. Are you ready? All right. What are you going to make the u? So I look at this and I'm like, well, that helped me. Let's do it. Okay, don't write this down. It's okay. Look, don't write this down. Just if I make u equal to cosine x, du equals negative sine x dx. Does it look like that will help me? Notice that I have a sine squared there. No. So now, what's the other option? No, not 1 minus sine x.
Oh, sine squared x.
No.
Oh, would it just be negative sine it?
Yes. Well, look, you see this cosine x dx? That's what we're trying to get rid of, like to substitute with. So if I make u equal to just sine x, child, but how is that possible? Well, you'll see right now. Look, if I make u just sine x, what is my du? Cosine x dx. Now look at that. I can do substitution, and now I'm just going to have this integral, parenthesis, 1 minus u squared, close it, and this right here is just going to be my du. This is kind of tough. That's more like a Cal 2 problem than a Cal 1, than a Cal AB. But I just wanted to make sure that you know that it's possible. No, I want to make sure you're going to be a future engineer, future doctor, future mayor, future electrician, future physicist. Do you guys see how that makes it a lot easier? Now I'm taking an integral with respect to what letter, Miss Kyle? U. What's antiderivative of 1 with respect to u? U. What's antiderivative of u squared with respect to u? Plus c. Do I have what u is? Yes, what is it? Sine x plus sine cubed x over 3 plus c. Oh, it should be minus. Should be minus. Yes, marinate. Yes, but remember we thought for C in the first semester. But now with limits, we're just probably going to go that route. Job, how can I get help with this?
The problem I'm having is knowing what U is.
Yeah, that's the whole thing. Like, what is?
That's my main. I don't know what. That's her problem. That's my problem.
Period. Whatever the simplest thing next to dx. If the opposite is
No. It's just you just gotta look at the whole expression and say, what can I do to substitute to make the integral simpler? And it just takes a lot of practice. What was my original question? Cosine cubed? Look, I hope that it tells you, I don't know, it might or it might not, to do U-substitution. Cosine x, and then let me put a parenthesis to the third power with x. So let's see what it tells me. And I'm going to push enter. And it doesn't tell me crap. Can I say that? Look, here's the answer. Isn't that what we got? Sine x minus sine cubed x over 3 plus constant. But it doesn't give me any hints on how they did it. Expanded trig form, reduced alternate form of an integral, series expansion. That's for BC. You're going to get there eventually. Okay, well, here's how you can check, but that's not a, I don't like it. Okay, tell me, Kyle, what are you thinking about? Yeah, I'm gonna print out a new handout for you guys. I don't want you guys to go into Delta. I'm gonna print out a handout for you guys in a little bit, and I'm gonna tell you the first few. I'm gonna tell you what U is, and then after you do that, then you know what I mean. So that's what I'm gonna do. So in a little bit, I'll print it out for you guys. All right. Do we feel okay?
I feel all right.
You feel all right?
Now we have to do it with definite integrals.
Yeah, but it becomes a lot simpler in my opinion. The whole point, what's the whole point of U-substitution? To make the integral simpler. Yeah, we're about to. Do you see how?
Wait, you would be 10, right?
Yes, but you're getting ahead of myself. Yeah.
Because the derivative of 10 is secant squared.
Yes, but you're getting ahead. Yes. All right. You see how this is a definite integral? And you have limits. So you're not going to go back to your x. It's about you. Do you see it? No, guys, stop. You guys are funny. So here's what we're going to do. You're going to make this simpler, and we're not going back to the x. Why? Because we have limits. Put that in your brain. If there's limits, you do not go back to the x. Now, if you don't have limits, it was never about you, so you go back to the x.
Set up battle.
No, but do you see what I mean? So if you have limits, are you going back to your x? No. Also in real life, don't go back to your x either, guys. Now you're just asking for trouble. Yeah. I mean, an x is an x for a reason. Don't go back to them, please. You're just asking. I've only heard in all my life, I've only heard of one person that married and divorced, and then 10 years later got married back to the same person. And they're the only people that I know that have been happy. I've never heard of anyone else getting married again with the same individual. So, guys, once they're an ex, leave them alone. They're an ex for a reason. Stop it. Okay. All right. Here we go. Hey, stop. Let's focus. All right, here we go. All right, Mia Cruz, ready? So look what Mia Cruz said. I need to make this simpler. All right, guys, focus. So you look at that and you're like, man, I don't know how to integrate that, but Mia Cruz said something. Mia Cruz said, what's the relationship between tan x and secant squared?
The derivative of tan x is secant squared x.
So your u has to be?
10, so then whenever you take the u, it would be secant squared x dx. So then you would be able to...
There it is. Do you see what we're doing, guys? You get better the more you do this. So I'm going to write integral. Notice that I'm not putting limits yet because I'm going to need new ones. And I'm replacing the tan x with u. And I'm replacing the secant squared x dx with du. That's a way simpler integral. Yes, but not yet. Everyone here? Okay, how do I get my new limits? You focus on this and you say, okay, when x is 0, what is tan of 0? 0. Put a 0 so that one doesn't change. When x is pi over 3, what is tan of pi over 3? A little bit of pre-count, not much. Square root of 3 over 2 divided by half, so it just becomes Just a little bit of pre-calc, guys. It doesn't go away. So there it is. Do I have to go back to the x? No, we're done. This is equal, guys. This integral right here is the same value as the integral on the top. It's the same. So there's no reason to go back into x's or anything. You're just gonna do upper minus lower. So here we go. Antiderivative of u. What's antiderivative of u? Put a little line, put a 0 on the bottom, put a square root of 3 on the top. Yes, if you want to have the divide by 2 on both terms, you can, upper minus lower, but make life simpler. If both terms have the 2 on the bottom, can't I just factor it out? So make life simple, guys. Here it is. 1/2 factored out, parenthesis, square root of 3 squared minus 0 squared. I just put the 0 there for formality. Say it again. Yes. Upper minus lower.
So it would be square root of 3 squared over 2.
Well, square root of 3 squared is what?
Oh, it's 3, so it'd be 3 over 2.
She actually did say it right because she said square root of 3 squared, which is 3 over 2. And there it is. Ain't no yawning. That's a demerit. What, you think I wouldn't catch you? I caught you, miss. Are we okay? Okay. Hey, stop.
Jocelyn keeps making fun of me.
All right, here we go.
Why does everyone hear Jocelyn bullying me all the time, but nobody reports?
Okay, Miss DeLeon, stop bullying her.
I'm not bullying
All right,
her.
here we go.
I didn't say worse stuff.
Let the record show I tried to prevent bullying. Okay.
Okay, I did my part. Okay, but Mary,
Yeah, I did my part.
You heard me say
All right. Let's focus on this. Okay, here we go, guys. I'm looking at it, and it says I have an x squared minus 4 in the denominator. I have an x in the numerator. What should the u be? X squared minus 4.
You got that.
If u is x squared minus 4, then du is going to be, I'm just taking a derivative, 2x dx.
Third, 2x. No, 4x to the third. No, I don't know.
I don't know what you're saying.
I'm getting confused
all right.
between antiderivatives.
Here we go. Do I have a 2x dx in there? No, but I can force it. If I put a 2 right in front of that, what I put in front of the integrand? 1/2. Do you guys see what we did there? All right, here we go. I have 1/2 integral, and then the 2x dx is just du over u. Now I need limits, so I'm going to slow down. Yes.
For D, where did you get 2x? Why 2x?
The derivative of x squared is 2x.
Oh, okay.
So 2x. No, you're fine. All right. When my lower limit is 0, when the x is 0, what are you plug it in right here. Yeah. 0 squared minus 4, what are you going to get? Negative 4.
How do you know to put
Wait, both of them would be negative.
Say it again.
How do you know to put it into the denominator?
This is the next value, miss. So I'm just trying to get new u values. A new lower limit u value and an upper limit u value.
So we just put it
Into wherever you see the x, see? To get my new u. My lower limits for u.
I understand it now.
When x is 1,
-3.
what do you get for u? Negative 3. Negative 1 squared is 1. 1 minus 4 is negative 3. Are we still okay? All right, so here we go. I'm going to rewrite it. 1/2 integral negative 4 to negative 3 of 1 over u du. Are we still okay? Okay. Equals 1/2. I'm going to put a bracket. What is the antiderivative of 1 over u? ln. And I got to put absolute value of u. Close it. Negative 4 lower limit. Negative 3 upper limit. Are we still okay? You can, if you want, have the half on both terms, but just leave it factored out, guys. So here it is. 1/2 factored out. Bracket. I'm just doing upper minus lower. ln absolute value of negative 3, close, minus ln absolute value of negative 4, close, close. Are we still all right? Absolute value negative 3 is just, absolute value negative 4 is just, what's ln of 3 minus ln of 4? If you want to reduce it to 1 ln?
3 over 4.
ln of 3 over 4. 1/2 ln of 3 over 4.
Because whenever you subtract that, it's divided.
Yes. Can you see all the algebra that's happening? Don't worry, we'll be fine. This is the last page, I believe. You guys ready? So they're telling us, let f be a function such that, so this is true. Negative 18, 9, f of u du equals 3. So they're telling us that that function right there is 3. We're still okay? All right. So let's see. You see how we have a 3x right here? So they're probably telling us that we're probably going to have to do some type of substitution. Do you guys see that? So I'm going to go ahead and just say, okay, well, I guess they're kind of giving us a hint. So I'm going to say that u equals 3x. So what does that mean that du is? 3 dx. Do you guys see that? All right, so here's what I'm going to do. I'm going to take this, and I'm going to use this information, and I'm kind of going to go backwards. So I'm going to write an integral. Notice that I'm putting u limits in a little bit, not yet. And instead of u, I'm going to write what? 3x. So f of 3x. 3x, I put a 3 there. Close it, and then instead of du, I just replace du with 3dx. Don't worry, I'm going to fix it right now. Are we still okay? This is all being multiplied. So you see that 3? I'm going to move that 3 to the front. 3 integral f of 3x dx. I almost have it looking like that. Almost. So when this... Okay, I'm going to slow down. Let me color code it. This was a u. See, because that says u. When u was 18, what was x? So let's see. Negative 18 equals 3x divided by 3, divided by 3. What's negative 18 divided by 3? Negative 6. Do you guys see how he got that? All right. When u was a 9, what was x? 9 equals 3x divided by 3, divided by 3. What was x? 3. And so there it is. So I'm going to put negative 6, 3. What's up? Okay. Oh, wait. What was the question? I haven't finished, guys, but we're paused. They want to know what the integral from negative 6, 3 of f of 3x dx is. I already knew this much. I already knew that this integral was 3. So this right here that I just did, let's see. This right here, they're equivalent, right? So this just equals 3. But hold on. They don't want to know the integral of 3, integral negative 6 to 3 of f of 3x dx. They want to know just the integral from negative 6 to 3. So how do I get rid of that 3 there? Divide. Whatever you do to one side, you do to the... So what does that integral mean? Or equal? Just 1.
All of that,
Yes. Hit me.
For the negative 18 and the 9, why did you do that? Why did you do the 3?
Oh, because these were in terms of u. I needed it in terms of x. And so I have a new x. So I said, okay, when u is negative 18, what is x? And I got negative 6. When u is 9, what is x? And I got 3. What's up?
If what they gave us instead of FU du was fx dx, we would have just put it into dx, right?
Yep.
It just depends on what they gave us.
Yep. Exactly. Cool. All right. One more, and then we'll call it a day. Are we cool, guys? All right. And no delta. We're going to practice with handouts, and I'll go print it out right now, so we'll take a 5-minute break. All right. So I have integral 0 to 1 of 3x squared square root of 9 minus 5x cubed all over 2 dx. It looks ugly. What am I going to make my u? 9 minus 5x cubed. Because that has a degree of 3, and when I take a derivative, So u equals 9 minus 5x cubed. Are we still okay? Yes. Yes, I have a polynomial with a degree of 3. So whenever you take a derivative of a polynomial, it goes down 1 degree. And guess what I have on the outside of that square root? The degree of 2. Do you see it? Yeah. So here we go. du equals, what's the derivative of 5x cubed? And then I put a dx. All right, here's what I'm going to do. I see a 3 and I see a 2, and those are constants. 3/2. I'm going to pull that outside. So I haven't done anything yet. I'm just rewriting it to make it easy for me.
So then it would just be x squared times. So.
Okay, there we go.
Yeah.
Here's what I'm going to do. I see a negative 15. That's what I'm going to put in here. If I do that, I put on the outside negative 1 over 15. All right, now here's what I see. Let's see, does 3 go into 15? It does, right? 5 times. So I see negative 1/10 integral. I'm going to put new limits in a little bit, guys. The negative 15x squared is du, but put that at the end. Square root of u. So the du is understood to be the end of the differential. Does that make sense? All right, I need new limits. When x is 0, what is u? 9. When x is 1, what is u? 4. Ooh, this is a perfect candidate for reversing the limits. This is a perfect candidate. You see how the lower limit is 9 and the upper limit is 4? And I have a negative on the outside? If I reverse those, that negative goes away from the integral properties. Are we okay with that? Is there any reason for us to go back to our x here? No. Here we go. This is the same thing as u to the half. Remember that. Antiderivative of u to the half. U to the 3 over 2 divided by 3 over 2, which is the same thing as 2/3. And I have a 1/10 in the front of that. Line 4/9. We're almost done, guys. We're almost done. How many times does 2 go into 10? So here's what I see. Factor out the 1/15. Giant parenthesis. Child, I need a calculator for this. No, you don't. 9 to the 3/2. We'll talk about how we'll combat that in a little bit. Minus 4 to the 3/2. Close. We're still okay? Okay. 1/15 parenthesis. Here's how you do it, guys. It doesn't matter which one you do first. You do the one that you think is easier. Yeah, the square root of 9 cubed. Yeah. What's the square root of 9? 3. And 3 to the 3rd power? 27. Minus, what's the square root of 4?
2.
And 2 to the 3rd power? 8. 27 minus 8? 19. No? So 19 over 15. How do you feel? Yeah, this 9 to the 3/2 means this. Cube root of 9 cubed, and then the square root of 9. It doesn't matter which one you do first. This is equivalent to saying this. Square root of 9 raised to the power 3. Okay. That's it. What do you guys think? Was today tough?